Today's lesson is from section 7.2 in the text, the mean and standard deviation of the sample mean. So, the goal for these notes by the end is to be able to approximate the population mean and standard deviation using the real world penny problem. So we took time and we took lots of samples of pennies and found their sample means and made a sampling distribution over the past couple of class periods. And in reflection and then also application to this new lesson, we'll fill in these blanks. We created sampling distributions of sample means. Right, and that's where we took and we wrote down the different dates that the pennies were made, and then we made a dot plot, and it became when we had large enough samples, our dot plot started making the shape of a normal curve. So although as a class we calculated many sample means, we did not have an exact sampling distribution. We had a sampling distribution, but it wasn't exact because we did not have all possible sample means. So, although we had lots of sample means, we did not have all possible different samples from that population of pennies. So here's some notation to be familiar with. The mu symbol, we know that that means population mean, or the mean of the variable. And when we have a subscript like this, it's referring to what variable we're finding the mean, the population mean for. So in this case, the mean of the variable y is represented by mu sub y. Mu sub x bar is the mean of x bar, or the mean of the sample means. And then sigma sub x bar, so that would be the standard deviation of x bar. Another name for the standard deviation of the variable x bar is sampling error. Because the standard deviation, right, that's our distance from the mean, that standard deviation determines, so the standard deviation of x bar determines the amount of sampling error to be expected when a population mean is estimated by a sample mean. So if you recall from the penny experiment, our goal was to get as close as possible using a lot of different sample means to figure out the population mean without actually having to line up each one of those pennies and find the average. So here's an example. The mean of the sample mean. So heights of starting players, the heights in inches of 5 starting players on a men's basketball team are repeated in table 7.5. So here the population, here's this table 7.5, and here the population is 5 players. A very small population just for the purpose of us understanding this concept. And the variable is height. So here's each of our players, and here's each of their heights. It says determine the population mean mu. So we're in the space below, we're going to find mu, and we know how to find mu. We do that by adding up. This is the notation that we should be familiar with. Add up all the x values and divide by capital N, the size of the population. That's your 76 and 78, 79. 81, and 86 straight from the table, divided by 1, 2, 3, 4, 5. And when we calculate that, we get 80 inches. So mu is 80 inches. B, it says obtain the mean mu sub x bar of the variable x bar for samples of size 2. So this is kind of a new way of talking about things. So we want to find all possible samples of size 2. So this is actually a chart of all the different ways we could arrange the letters A through E with just 2 members each. And thankfully, this has all been calculated for us. So the mu sub x bar can be calculated by adding each one of these together and dividing by how many there are. There are 10 different ways to arrange when you have 5 items in the set and you want to choose 2. When we calculate the mean of all possible sample means, we get, again, 80 inches. We'll do that again one more time. We'll do that on the back. Repeat for sample of size 4. So again, nice that this has been done for us. Here are the possible samples of size 4, and here are the means. We can find mu sub x bar, this time defined by a size of 4 for the sample size, by adding up each one of those, 78.5 and 79.75 and 80.25 and 80.5 and 81 divided by 5, and for that we get 80 inches. So as you can see, because we have a really small population of 5 players, it is reasonable to do all possible samples and find each one of the means and calculate an exact value for mu sub x bar because we have a full sampling distribution, which was not the case when we had a huge population like we had with the penny activity. The next question is going to have us find the sample standard deviation of the sample mean, similar to finding the mean of the sample mean. So if we go through each one of these steps, step A, determine the standard deviation sigma. So we could do that. Come on in. So recall sigma is equal to the square root of the sum of all of, sorry, I put that in the wrong spot. We're going to add up all of the differences where we subtract the population mean from each individual value and square that, and then we would divide by capital N. When we do that, and I recommend using Microsoft Excel, we get for our value 3.41 inches. Part B, it says to obtain the standard deviation S sub x bar of the variable x bar for sample of size 2. So in this case, we actually need to look at each possible way that we could have that sample of size 2 and find the standard deviation. So we already had that in our table, right, back on the back, or sorry, back to the front. So for part B, we're going to do sigma sub x bar, where sample is size 2. And when we enter in each one of these values here in a Microsoft Excel spreadsheet, you get a value of 2.09 inches. If we did that for all possible sizes for this data set, size 1, size 2, size 3, size 4, and size 5, you would get the following standard deviations. So what you see here is as the sample size increases, like you saw with the penny experiment, the standard deviation decreases. We have 0 standard deviation because we've accounted for every single member of the group by sample size n equals 5. So this is what you'll be applying in your Math Excel assignment for today.